Welcome to the deep dive. I want you to picture something for a second. Just imagine you are holding a tiny bare circuit board right in the palm of your hand.
Just the raw hardware.
Exactly. You can see the exposed pins, the silver ports, the little microchips, and it really doesn't look like much, but what you are holding has the potential to become almost anything.
It really is a blank canvas.
Right. I mean,
Right,
it could
yeah.
be a full-fledged desktop computer or, the brain of a custom robot or even a smart home hub that automates your entire house.
And that blank canvas can be a bit intimidating, especially if you've never worked with the raw hardware before.
Oh, absolutely.
You aren't just taking a sleek aluminum laptop out of a box and, pressing a single power button. It asks more of you.
Which is exactly why we are tackling this today. Our source material for this deep dive is the official, completely up-to-date Getting Started documentation directly from Raspberry Pi.
And that includes the newest hardware, too.
Yeah, we are looking at the foundational setups for all their hardware, right up to the newest flagship models, like the brand new Raspberry Pi 500 Plus RAW.
Which is a beast of a machine. But reading through technical documentation, even exceptionally well-written documentation like this, it can sometimes feel a bit dry.
Oh, for sure. If you don't know what you're looking for, it's tough.
Right. It's so easy to get lost in the specifications and completely miss the broader possibilities of what you can actually build.
So our mission today is to cut through that technical manual. We want to extract the exact aha moments and the crucial steps you actually need to know.
To get you to the fun part faster.
Exactly. We want to transform this piece of hardware into a fully functioning, customized machine. The goal here is to make setting up a Raspberry Pi feel less like an IT chore and more like a really exciting creative project.
Because once you understand the logic behind how these devices are put together, you realize you have total control over the technology.
You're in the driver's seat.
Yeah, you decide what it does, how it operates, and exactly how it connects to your world.
Okay, let's unpack this. I like to think of this process a lot like prepping for a recipe in the kitchen.
I like that analogy.
Right. Because a Raspberry Pi does not come ready to just plug into the wall and play. You, as the chef, have to supply the lifeblood, which is the power and the memory, the storage, where the brain actually lives.
The essential ingredients.
Exactly. And looking at the sheer variety of Pi models in these documents, the physical prerequisites vary quite a bit. So how do we break down the physical ingredients we actually need to gather first?
Well, the foundational ingredients always boil down to power and storage. So let's start with power.
Okay.
What's really fascinating here is how clearly the power requirements map to the evolution of the devices themselves.
Meaning as they got more powerful, they literally needed more power.
Exactly. If you're working with the older models, and by that I mean the Pi 0 series, the Pi 1, the Pi 2, and the Pi 3, the documentation specifies you need a 12.5-watt micro USB power supply.
Which is basically just the older standard phone charger most of us have sitting in a junk drawer somewhere.
Correct. Those older boards were designed to be extremely low power. But as we move up to the modern powerhouses,
The new ones.
right, the Raspberry Pi 5, the Pi 500, and that new Pi 500 Plus you mentioned, the game has completely changed. These machines are incredibly capable.
They're essentially full desktop computers at this point.
They really are. And because of that, they demand a lot more juice. For those, you're going to need a 27-watt USB-C power supply pushing 5 volts at 5 amps.
Wow, okay, that is a significant jump. So trying to power one of those new models with an old Kindle charger is going to cause some problems.
It absolutely will. The documentation notes a very specific limitation if you try to underpower the newer models.
What happens? Does it just not turn on?
Well, if you use a standard 5-volt, 3-amp USB-C supply on a Pi 5 or 500, the system will actually recognize that and throttle itself.
Oh, really?
Yeah, it will limit your USB peripherals to drawing only 600 milliamps of power.
Meaning if you try to plug in a power-hungry external hard drive,
It won't work.
it might just click and fail to spin up because the board is literally starving for power.
Precisely. So the takeaway there is to not skimp on the power supply if you have a newer model. Get the 27-watt version.
Gotcha. Now, what about the storage? Because unlike a laptop you buy at the big box store, there is no internal hard drive soldered onto this board, right?
Right. The Raspberry Pi lacks onboard storage for its operating system. You have to provide the drive yourself.
So what do most people use?
Most users start with a standard microSD card, and the documentation recommends at least 32 gigabytes if you want the full graphical desktop experience.
Makes sense.
But there is a very specific hardware quirk mentioned in the sources that users absolutely need to be aware of if they're working with vintage hardware.
See, hardware quirks are always the things that trip people up the most. What should we be looking out for?
If you happen to be using a Raspberry Pi Zero, a Raspberry Pi 1, or an early model of the Raspberry Pi 2,
Okay.
your boot partition absolutely cannot be larger than 256 gigabytes.
Really? Why is that?
It is a strict hardware limitation related to something called the master boot record.
Okay, let's break that down for a second. The master boot record is essentially the index card or the table of contents for the storage drive, right?
That's a great way to picture it. It tells the computer where to look for the operating system.
And the older chips just can't handle a big table of contents.
Exactly. They simply cannot read a table of contents that goes past 256 gigabytes. The numbers are literally too big for its architecture to process.
Oh, wow.
So if you buy a massive, modern 512 gigabyte micro SD card for your old Pi Zero, it simply will not boot. You'll just be staring at a blank screen.
That would be incredibly frustrating. You'd probably think you broke the board.
You definitely think the hardware was dead.
Speaking of staring at screens, the display situation is also quite a journey through tech history. Looking at these docks, you really have to check your physical ports before you buy any cables.
You do. Because it's a highly modular system, the engineers fit the ports to the physical size of the board.
Right, like if you have the newest Pi 4 and 5 series, including the keyboard models like the 400 and 500, they use micro HDMI ports.
Yes.
And they actually give you two of them side by side, so you can run dual monitors straight out of the box.
Which is amazing for productivity.
But then, if you have the tiny Pi Zero, which is about the size of a stick of gum, it uses a mini HDMI port.
Different cable entirely.
Yeah. And then, if we go back to the older, larger models, they have a full-size HDMI, but they also have this incredible retro feature composite video out.
The documentation points out the 3.5 millimeter TRRS jack.
Right. For anyone unfamiliar with that acronym, it looks exactly like a standard headphone jack.
Just a normal audio jack.
But if you look at the metal plug of the cable, it has an extra little ring on it. That extra ring pushes out old-school analog composite video along with the audio.
Which means you could literally hook an older Raspberry Pi up to a wood-paneled CRT television from the 1980s.
That is so cool.
It's why these older boards are so beloved for retro gaming projects. You get that authentic, fuzzy scanline experience.
I love that they kept that in.
But there is one major modern display limitation that the documentation highlights very explicitly regarding the newer boards.
Okay, let me guess. It involves the USB-C port?
It does. Because the newest boards use USB-C for their main power delivery, a lot of people naturally assume they can use that same USB-C port to connect to a modern monitor.
Just like they do with their expensive laptops.
Exactly. Relying on what the industry calls DisplayPort Alt mode.
But it doesn't work.
The documentation states clearly, no Raspberry Pi model supports video over USB-C. You absolutely must use the dedicated HDMI outputs for your display.
Wow. Okay, that is a massive detail to highlight. Do not buy a fancy, expensive USB-C monitor expecting a one-cable setup for your Pi because it simply won't send a video signal.
It's a very common mistake.
I bet. Okay, so we have our board, we have our beefy 27-watt power supply, our micro HDMI cable, and our blank, appropriately sized micro SD card. Here's where it gets really interesting.
The software side.
Yes. How do we actually get a brain into this thing? How do we put an operating system onto a completely blank piece of plastic?
This brings us to a piece of software that the Foundation provides called the Raspberry Pi Imager.
Okay.
And honestly, it fundamentally changes the user experience compared to the early days of microcomputing. You download and run this program on your regular everyday computer. It's available for Mac, Windows, and Linux.
So you use your current computer to prep the Pi's computer.
Exactly. It essentially acts as an intelligent bridge between the blank SD card and the operating system you want to run.
Because back in the day, you had to mess around with complex command line tools just to flash an SD card. It was terrifying.
Oh, very unforgiving.
Because if you typed the wrong drive letter, you could accidentally wipe your main computer's hard drive.
It was a stressful rite of passage for early adopters. But the Imager eliminates all of that anxiety. It even has a built-in safety warning if you accidentally select your computer's main system drive instead of the SD card.
Thank goodness.
Right. But the true power of the Imager isn't just downloading and copying the operating system, it's the customization step.
Walk us through this customization step, because reading through the sources, this seems like the secret sauce to the whole platform.
It really is. Before it writes a single byte of data to your SD card, The imager lets you pre-configure the operating system settings. And if we connect this to the bigger picture, this is what allows for what we call a headless setup.
Setless, which sounds a bit spooky, but let's ground that concept.
Okay.
Imagine you want to use your Raspberry Pi to build a weather station and you plan to mount it up in your attic. You really don't want to drag a computer monitor, a keyboard, and a mouse up a ladder into a dusty attic every single time you need to update the software or check the data.
That sounds like a nightmare.
Right. So a headless setup means the Pi operates without a monitor, a head, and without a keyboard attached. You control the whole thing remotely from your laptop while sitting comfortably on your couch.
That is the perfect use case. And to achieve that, you need the Pi to automatically connect to your network the second you plug it into the wall in that attic.
So how does the imager help with that?
In the Imager's Customization tab, you can set the device's host name. So instead of trying to find a random cryptic IP address on your home network later, you can just tell the Imager to name the device Weather Station.
Nice.
Once it's running, it will be accessible at weatherstation.local.
That alone saves so much headache. And then there is the Wi-Fi setup.
Yeah, this is brilliant. If you are running the Imager on a laptop that is already connected to your home Wi-Fi, the Imager will automatically pull your current network's name, the SSAD, and pre-fill it in the settings.
It just knows.
You just punch in your Wi-Fi password, and your Pi will automatically join that network on its very first boot. You can also set your local time zone and keyboard layout right there.
And for the users who want to securely manage that attic weather station from their couch, there's the SSH configuration.
Secure Shell, yes. This is the protocol that allows you to open a remote text terminal into the Pi. The Imager lets you enable SSH and choose your authentication method right from the start.
So you don't have to hook up a monitor to turn it on.
Exactly. You can use a standard password, or for much higher security, you can tell it to use public key authentication.
Let's translate that for a second. A public RSA key is essentially a digital VIP pass.
I like that.
If you have this key on your laptop, you can drop a copy of it into the Imager. Then when the Pi boots up in the attic, it recognizes your laptop as a trusted VIP.
Which means your laptop is allowed to securely log in without you ever having to type a password. It's incredibly slick and highly secure.
It's just seamless.
And the documentation also details a relatively new feature in this customization tab called Raspberry Pi Connect.
Now, this stood out to me as a huge leap forward for accessibility. Traditionally, if you wanted to access your headless Pi from outside your house, say, you wanted to check your weather station data while sitting in a coffee shop downtown, you had to mess with your home router.
Yeah, you had to get into the weeds.
You'd had to set up port forwarding and dynamic DNS.
Which essentially involves poking complex, sometimes dangerous holes in your home internet security firewall.
Yeah.
It is a steep learning curve and very easy to get wrong.
And risky if you don't know what you're doing.
Exactly. But Raspberry Pi Connect bypasses all of that complex networking.
How does it actually work during that initial Imager phase?
Right in the Imager software, you click a button that opens your web browser, you sign into your Raspberry Pi ID account on their website, and it generates a single-use temporary authentication token.
Okay.
You paste that long string of text back into the Imager. Then, when your Pi eventually boots up, it uses that token to securely link itself to your account over the standard internet.
Without touching the router setup.
Zero router configuration. From then on, you can access your Pi remotely, securely, through a web browser from anywhere in the world.
So that completely changes the accessibility of remote management. It makes creating your own private, globally accessible server incredibly easy.
It really opens up the possibilities.
But wait, reading through this, I hit a logical wall.
Oh, what's that?
What if someone is listening to this and they buy a Raspberry Pi, a blank SD card, an Ethernet cable, and a keyboard, but they don't own a Mac or Windows laptop to run this Imager software on? They literally only have the blank Pi hardware. How do they get the software onto the card?
This raises an important question, and it highlights one of the most impressive engineering feats in the modern Raspberry Pi lineup. You are not stuck.
Really? How does it work?
It's called the Network Install feature. It is available on the flagship models from the Pi 4B onward, as well as the keyboard models like the Pi 400 and 500.
Okay, so modern hardware.
Yes, if you find yourself with no other computer, you plug your Pi directly into your internet router with an Ethernet cable. You insert your completely blank SD card, you plug in your keyboard and your monitor, and then as you plug the power cable in, you press and hold the Shift key on the keyboard.
And what is the board doing when you hold that key?
The newer Raspberry Pi boards have a tiny bit of essential firmware built directly into a chip on the board itself. By holding Shift, you are telling that firmware to bypass the empty SD card, reach out to the internet, and connect directly to the Raspberry Pi servers.
Wow.
It then downloads a special lightweight version of the Raspberry Pi imager straight into its own temporary RAM memory and boots it up on your screen.
It is pulling itself up by its bootstraps.
Literally.
It uses the internet to download the tool it needs to build its own brain. That concept of a self-bootstrapping device is remarkably elegant. You can start with absolutely nothing but the bare hardware and a network cable and end up with a full, customized operating system.
It is a brilliant solution to a very common roadblock for people who are trying to use the Pi as their very first computer.
So what does this all mean for the actual setup process? We've got the OS on the card now, whether we used our laptop or that clever network install trick. We plug everything in, we connect the power, the status LED lights up, and we are looking at the very first boot on our monitor. If we didn't use the pre-configuration customization we talked about earlier, what happens next?
If you skip the customization, you'll be greeted by the first boot configuration wizard on your screen. And the documentation outlines a few very specific sequence steps here that are crucial for a smooth experience.
What's first?
First, regarding peripherals. If you happen to be using a USB Bluetooth adapter for your wireless keyboard or mouse, rather than relying on the Pi's built-in Bluetooth, you must plug that little adapter in before you turn the power on.
Which makes sense because the very first thing the setup wizard does is automatically scan for and pair Bluetooth devices.
Exactly.
If that adapter is sitting on your desk when the system boots, the wizard won't see your mouse and you won't be able to click on anything to proceed.
Precisely. Once your mouse is clicking, the wizard walks you through localization, your country, language, and time zone. But the most critical step comes right after that, setting up your user account.
Ah, yes. Historically, for years and years, every single Raspberry Pi shipped with the exact same default login credentials.
Everyone knew them.
The username was Pi, and the password was Raspberry.
Which was undeniably great for getting classrooms of students started quickly, but it was absolutely terrible for security.
Because if every Pi in the world has the same password, malicious botnets scanning the internet know exactly what credentials to try when they find a new device online.
Exactly why the Foundation changed the process. The modern setup wizard absolutely forces you to create your own unique username and password.
No more defaults.
Right. And the documentation explicitly notes a warning here. Even if you decide, out of a sense of nostalgia, to keep the username Pi, you must avoid using the old default password of Raspberry.
It defeats the whole purpose of the security update.
The wizard will actively encourage you to pick something secure to keep your device safe from automated attacks.
Please, use a real password. Now, moving on through the wizard, there is a fascinating little moment that feels like a microcosm of the open source world. It's the browser selection screen.
Yes, the wizard actually asks you to choose your primary web browser, Firefox or Chromium, which is the open source foundation that Google Chrome is built on.
But the interesting part isn't just the choice, it's what happens after you choose.
It takes action.
Yeah, the wizard will actually completely uninstall the browser you didn't pick. It aggressively purges the loser of that battle just to save you a few hundred megabytes of storage space on your SD card. It's ruthless, but highly efficient.
Storage space is precious on a micro SD card. And right after that browser battle, the system connects to the internet to check for software updates. It wants to make sure your new operating system has all the latest security patches and features compiled before you even see the desktop.
And I have to share this highly specific detail from the official docs. If you happen to be setting up the brand new Raspberry Pi 500 Plus for the very first time, the documentation literally warns that this initial update process can take up to half an hour.
It's a big update.
It explicitly suggests you go grab a cup of coffee.
You know, it's quite refreshing to see technical documentation with a bit of practical humanity. Compiling software updates takes time, especially on a major new hardware architecture.
Definitely.
It's much better to know that up front, so you don't sit there staring at a progress bar, assuming the system is frozen and pulling the power plug, which could corrupt the whole setup.
Go take a walk, read a book, and then you come back, the Pi reboots one last time, and boom, you are on the desktop.
You made it.
You have a full graphical interface running on a computer the size of a deck of cards. So what are our immediate next steps to make this hardware actually useful?
The documentation strongly points new users toward the recommended software menu, which you can find by clicking the little Raspberry icon in the top left corner of the screen.
Because it doesn't come bloated with software.
Right. The base installation is intentionally lightweight to save space. So this menu is where you go to actually equip the machine for your specific needs.
So if you are wanting to use this Pi as a daily driver, a real home PC for checking email and doing homework, you can go into that menu and grab LibreOffice. And just like that, you have a full free suite for writing documents, making spreadsheets, and doing presentations.
And equally important is the Universal Access section in that same menu. The documentation specifically highlights built-in tools like the Orca screen reader and the screen magnifier.
That's awesome.
It's a vital reminder that this hardware is designed to be highly accessible and customizable for all users, regardless of visual impairment.
It's technology that adapts to you, not the other way around. Let's take a step back and look at the journey we've just been on with this documentation. We started with a bare circuit board.
Just raw hardware.
We figured out that the robust new models need a beefy 27-watt power supply to keep USB drives spinning, while the older ones can run on a standard phone charger. We navigated the MBR storage limits and learned that USB-C is for power, not for video. You need those dedicated HDMI cables.
Then we walked through the utility of the Raspberry Pi Imager, exploring how to pre-configure a headless setup with Wi-Fi and SSH keys for remote management.
We talked about the incredible network install trick where the Pi bootstraps itself over the internet using just the Shift key. And we navigated the first boot wizard, keeping our devices secure by ditching the old default passwords and picking our champion in the browser wars.
Ultimately, what this documentation demystifies is the barrier to entry. It takes what seems like complex computer engineering and breaks it down into a series of logical, manageable, modular steps.
That is the biggest takeaway for you, listening right now. Whether you are prepping to build a retro arcade machine for your living room, setting up a headless web server in your attic to host your own blog, or you're just incredibly curious and catching up on modern microcomputing, this modular approach means you are in total control of your tech.
You really are.
You aren't buying a locked black box from a massive corporation. You are building it exactly how you want it, from the power supply up to the web browser.
And that level of control is deeply empowering. It fundamentally changes your relationship with the digital devices in your home when you know exactly how they are put together.
Before we go, I want to leave you with a thought to mull over. We've spent this whole time talking about how to get this hardware up and running, getting to the graphical desktop, or getting that remote terminal access. But think about the broader implications of what you've just built using these steps.
It is a profound shift in capability for an individual user.
You now have a tiny, silent, low-power computer that costs pennies to run continuously on your home network. And with features like Raspberry Pi Connect, it is securely accessible to you from anywhere in the world without needing a degree in network engineering.
That changes everything.
So the question is, what entirely new private digital infrastructure could you build for yourself?
The possibilities are endless.
If you have this capable machine always on and always yours, could you completely bypass the need for massive, centralized cloud companies to store your family photos, manage your smart home devices, or host your personal files? What does your personal private internet look like when you are the one holding the actual hardware?
That is the real power of learning this platform. The setup process we discussed today is just the beginning of that journey.
Thank you so much for taking this deep dive with us today. We hope you've had a few aha moments, and we can't wait to see what you build. Until next time, keep exploring.